Hello there, Nareg is here, and today we're going to talk about how to study the variation of polynomial functions, and especially in this case, quadratic functions. Of course, it comes from quadratic polynomials, but first I'm going to talk about the steps that you should follow in order to study almost any function. So what are these steps? Let's start. The first step is to talk about the domain of definition. So the first one is domain of definition. The second one, once you have done the domain of definition, you should talk about the limits. You should calculate the limits. And of course, regarding the values that you have in your domain of definition. The third one is about the derivative. So it's about the derivative. Once you have calculated the derivative, you can simply go and do the table of variation. Table of variation. Fourth point, you can choose some particular points. So the fourth step is to choose some particular points which are going to help you to draw your curve. Fifth step is to study any symmetry if you have. Of course, we're going to talk about the symmetry. And sixth step is to draw the curve. Okay, so I'm going to take an example. The first example will be a polynomial quadratic function. So let's take, for example, f of x is equal to x squared plus 2x minus 3. So it's a second degree equation. It's a polynomial which is quadratic. Since it's polynomial, you can directly say that the domain of definition, df, is equal to minus infinity to plus infinity. There are no values which I should be rejecting. I will have to consider the whole real numbers. The second step is to study the limit. So I'm going to calculate the limit when x tends towards minus infinity of my function, which is x squared plus 2x minus 3. In this case, since it's x which is tending towards minus infinity or plus infinity, it's the same, of course. You can choose the monomial of highest degree. It will be x squared. So what remains is minus infinity to the power of 2. You'll have to do the replacement, and the result will be plus infinity. The second part is to study the limit of x tending towards plus infinity of the same function, of course, x squared plus 2x minus 3, which is the limit of x tending towards plus infinity. You can choose the monomial of highest degree, x squared, and you will have to do the replacement. So it's plus infinity to the power of 2. The result will be plus infinity. Once you have studied the limits and you have also already defined your domain of definition, you can go to the derivative. So the derivative will be, our function is f of x is x squared plus 2x minus 3. We will have to calculate the derivative. F prime of x is equal to 2x plus 2. In order to study the sign of this derivative, you will have to say f prime of x is equal to 0, which means 2x plus 2 is equal to 0, which means again 2x is equal to minus 2, x is equal to minus 1. So this is the value which I should be considering. I will have to go to the table and make the table of variation. So x, taking values from minus infinity to plus infinity, passing by our value minus 1, x is equal to minus 1. F prime of x will be 0 for minus 1. It will be positive on the right side and negative on the left side. Of course, you can check the coefficient of your equation. In this case, the coefficient is plus 2. That's why I will have to choose plus on the right side. But in case it was negative, I should have placed a negative sign on the right side. Or you can simply choose any value of x greater than minus 1 and replace in f prime of x. For example, for x is equal to 0, which is greater than minus 1, you will have 2 times 0 plus 2, which is positive. Again, it's a positive value. You will have to put the sign plus. Alright, once you have done the table of sign of f prime of x, you can go to the table of variation of f of x, which is decreasing, and then it will be increasing. So in this case, you will have a certain minimum, an extremum, which is the minimum. For the limits, it's again plus infinity. We had already calculated, so you can replace them, plus infinity. And in order to calculate the minimum, you will have to calculate f of minus 1. You will have to replace in the initial equation, so it will be minus 1 to the power of 2. It's 1 plus 2 times minus 1, minus 2, minus 3, so it's minus 5 plus 1, it's minus 4. The minimum is minus 1, minus 4. Once you have your table of variation, you can choose some particular points and then directly draw the graph. So I will have to take a few particular points. Again, in this case, my function is x squared plus 2x minus 3. Let's say f of 0 will be minus 3. F of 1 will be 0. F of 2 will be 4 plus 4, 8 minus 3, it's 5. F of minus 1 we already calculated. F of minus 2, it will give me minus 3. F of minus 3 will be 0. And of course, if you want, you can calculate also f of minus 3, f of minus 4, f of minus 4. So in this case, it will be 16 minus 8. It will be 8 minus 3, 5. And right now I will have to draw my curve. As you can see, I have positive values, negative values. So let's start. So my curve, all right. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And again 1, 2, 3, 4, and 5. The minimum was for -1, -2, I guess, right? Let's check it. -1, -4. So -1, -4, it will be at this position. And then for 0, it's -3. For 1, it's 0. For 2, it's 5. For -2 is -3. For -3 is 0. And for -4 is again 5. So as you can see, my curve will have, it's a parabola of course, it will have this shape. This is the curve that I will get for this function. As you can see, I have a certain axis of symmetry, which is for x is equal to -1. How are we supposed to verify that x is equal to -1 is an axis of symmetry? It's very simple. I'm going to give you the formula also. So in order to check that x is equal to -1 is an axis of symmetry, you will have to go through this formula. F of 2a minus x, is it equal to f of x? I will have to verify. And of course, in this case, a will be equal to -1. It's the value of your axis of symmetry. So f of 2 times -1 minus x is equal to f of -2 minus x, and then I will have to get back to my function. My function was f of x, x squared plus 2x minus 3. Whenever I have x, I will have to replace it by -2 minus x. So it will be -2 minus x to the power of 2 plus 2 times -2 minus x minus 3. Once I will expand it, it will be 4 plus x squared minus, again it's plus in this case, since you can consider it's negative, so 4x, 2 times -2 minus 4, 2 times minus x, it's minus 2x minus 3. So your equation will be x squared plus 2x minus 3, which is exactly the initial function. So whenever I calculated f of 2a minus x, I was able to find f of 2a minus x is equal to f of x. So since I was able to verify this relation between these two functions, I can say that x is equal to minus 1 is an axis of symmetry. I'm going to take another example. Again, a quadratic function, a quadratic equation. But in this case, it will be with a coefficient which is negative. I'm going to give you another example. So the second example will be, in this case, so f of x is equal to minus x squared plus 4x plus 3. Again, the first step is to talk about the domain of definition. So your domain of definition, d of f, is equal to minus infinity plus infinity. There are no values that I should reject. We are working in the whole real numbers in this case, so you consider from minus infinity to plus infinity. As for the study, the second step, you should be considering the limits. So the limit of x tending towards minus infinity of your function, which is minus x squared plus 4x plus 3, is equal to the limit of x going to minus infinity of your monomial, which is highest degree, minus x squared, and then you will have to do the replacement. It's minus infinity to the power of 2, so you will have minus infinity as the final result. The same thing, limit when x tends towards plus infinity of minus x squared plus 4x plus 3, you can directly choose your monomial of highest degree. So it's for plus infinity minus x squared. I will have to do the replacement, minus plus infinity to the power of 2, so it will give you again minus infinity. Once the study of limits is over, you can directly go to the derivative. So we had our function minus x squared plus 4x plus 3, so the derivative will be f of x, it's minus x squared plus 4x plus 3, so the derivative will be f prime of x, which is equal to minus 2x plus 4. So in this case, again, to study the sign of f prime of x, you will have to say f prime of x should be equal to 0, which means minus 2x plus 4 is equal to 0, minus 2x is equal to minus 4, so x is equal to 2. And then you will have to go and study the sign of f prime of x regarding your table, x going from minus infinity to plus infinity, and the critical value is 2. So your f prime of x will be 0 for x is equal to 2, and then it will be negative on the right side since you have the coefficient negative and positive on the left side. So I'm going to repeat once again. You will have to check the coefficient. It's minus 2x, so it's minus 2. That's why I was able to choose negative on the right side. Alright, the variation of f of x will be increasing, decreasing. So in this case you will have a maximum. How do you calculate your maximum? Of course the limits are minus infinity, minus infinity. How do you calculate the maximum? It's very simple. You will have to calculate f of 2. F of 2 is equal to minus 4 plus 8 plus 3. So it's 11 minus 4, it will be 7. So your maximum is 2, 7. Once you have done your table of variation, you can take some particular points and then draw your curve. So the following step will be to take some particular points. Just 1 second. So x squared plus 4x plus 3. So f of 0, it's 3. F of 1 is equal to 7 minus 1, 6. F of 2 is equal to 4 plus, so it will be 8 plus 3, 11. 11 minus 4, 7. We had already done this value. F of 3 will be 12 plus 3, so it's 15, minus 9, it's 6. F of 4 will be 16 plus 3, it's 19, minus 16, it's 3. F of 5, so as you can see, it's on the positive side. It's mostly it's giving us positive values. F of 5, it will be 20 plus 3, so it's minus 2. And I will have to take the value f of minus 1. F of minus 1, it will be minus 5 plus 3 minus 2. Alright, so we're gonna draw our curve. In this case, you can consider the positive part as a dominant part. So our values are between minus 1, 0, 1, 2, 3, 4, and 5, let's say. And in this case, it will be 1, 2, 3, 4, 5, 6, 7. So the maximum is 2, 7. It will be at this position. And then you will have 1, which is 6. Again, 3 is 6. 4 is 3. 5 is minus 2. 5 is minus 2. 0 is 3, 0 is 3, and then you will have -1, which is again -2. So our curve will have the shape I'm gonna repeat once again. So it's almost this shape for the curve, and as you can see, it has a certain symmetry, which is again an axis of symmetry. In this case, it's most probably the value which is x is equal to 2. All right. So how do we verify that x is equal to 2 is an axis of symmetry? Again, we're going to use the same formula. F of 2a minus x, is it equal to f of x? So f of 2 times a is 2 times 2 minus x, is it equal to f of x? So f of 4 minus x, is it equal to f of x? So I will have to replace again in my function x by 4 minus x. So it will be minus 4 minus x to the power of 2 plus 4 times 4 minus x plus 3. It's minus 16 minus x squared plus 8x plus 16 minus 4x plus 3. So this will give me minus x squared plus 4x plus 3, which is equal to f of x. And this is how you can say that x is equal to 2 is an axis of symmetry. That's all for today. I hope this part was helpful for you. Next time I will be talking about the study of rational functions. I will talk about functions which are polynomial but from higher degree. So why not subscribe to my channel, and whenever a new video will appear, you will be notified. So don't forget to subscribe to my channel, and I can also give you my Instagram account, Facebook account, in case you have any questions, or if you want to comment or whatever, you can of course contact me. So that's it for today. I hope you enjoyed it, and hope to see you next time.